So today we'll be looking at simple machines, and specifically we'll be looking at levers. Now levers are a class of machine that again help you to do work. It's the same amount of work but with less force. So if you recall the equation, work equals force times distance, if we're doing the same amount of work, so the same size, but we increase the distance, we're going to need a smaller amount of force, which makes it easier. If we're doing the same amount of work, but we decrease the distance, we're going to need a much greater force, which makes it more difficult. So we're looking at first the three classes of levers. The first class of lever looks like this, where I have my load on one side and I am pushing down on the other side. Because I am pushing this down, I am my input force. This is the input force. And since this is the side without any machine, this is the output force. The way that I calculate this is the force out is really the same as the weight of the object. Whereas the input force depends on how much I can actually push. In the middle is the pivot point, or the fulcrum. Now, a first-class lever is special because the fulcrum will always be in the middle. An example of a first-class lever would be a seesaw, a crowbar, or even a pair of scissors, which would be an example of a double first-class lever. Next are my second-class levers. Second-class levers have the fulcrum or pivot point on this side, where the load is in the middle, and I am now pushing up on one side. So I am pushing up, or input force, on one side. In the middle, I am lifting my load, and on the one side is the fulcrum. Again, how this makes it easier is that the distance is increased from here to here to here to here. So my output distance is now being increased to this much as the input distance. When I increase the distance, my force needed becomes less. Examples of a second-class lever would include a wheelbarrow. Third-class levers are sort of an exception. Again, the fulcrum's at one side, but this time I put effort on in the middle. And the result is that there's an output force on the edge. Now, as you notice, the distance here is now actually less than if I was moving it without the machine. Now, based on this, we actually predict it to be more difficult. We decrease the distance. My d in is now less than my d out. So that means I would need a lot more force. That is true. I would need a lot more force. However, how this helps is that it actually increases the distance from the fulcrum. This allows the speed or the velocity to be increased. This is why we use a third-class lever, because the distance and the speed at the output end is greater than at the input end. An example of this is a baseball bat or a hockey stick. So these are the three classes of levers. First class has a fulcrum in the middle. Second class has the object or the output in the middle. And the third class has the input in the middle. So those are the three classes of levers.